So in the last class, just we had an introductory session, right? What is big data and why Hadoop drawbacks with the current
Hadoop is meant for
databases?
batch applications.
Yes.
So there are
Big
two
data
types of
like huge
applications.
volumes
What do you
of
mean by
data.
batch application? There are two types of
So
applications.
currently we have got a databases for storing the data.
There are two types of
Like Oracle,
applications.
MySQL, DB2, SQL Server, and we have got some specialized. Just I'll take 2 minutes what we have discussed in the last session. Specialized databases like Netezza, Vertica, and Teradata used for data warehouse purpose.
Online applications.
But these databases and specialized databases, they can handle data
batch
up to some
applications.
certain
What is the
extent,
difference
right?
between these
Beyond
two?
that, they cannot support
Online applications and batch
So we have got
applications. Hadoop is not for online
so
applications.
as a solution to
Hadoop
all
is
the
meant for
storage
batch
level problems
applications,
and
online
processing level
applications.
problems. We have got work like
User
Hadoop.
interactive applications. User interactive applications
is mainly meant for two things. Generally, any technology used either for storage or
user
for
interactive
processing.
applications.
They're used either for storage or processing, but Hadoop is used for both storage and
Here
processing.
user gives the input. User
Yes.
interactive applications. Here user gives the input. User gives the input.
And second, meant for processing. It is meant for both storage and processing.
Example,
Hadoop is meant for both
booking
storing
a movie
data and
ticket.
processing data. We talk about like C, C++, Java, .NET, all
Booking a
meant for
movie ticket.
processing. Oracle, MySQL, DB2, SQL Server, all meant for storage. But Hadoop performs
Making
both
a online
storage and
transaction.
processing. For storage, it doesn't use any databases
Making
because
a online
databases has got a
transaction.
lot of drawbacks as compared with this, right? So Hadoop is going with a special kind of file system.
Booking a movie
It's going
ticket,
with a
making
special
online
kind of file
transaction
system called as Hadoop
So
distributed
here compulsory, the
file
user need to use
system.
the input
And
like
for
source
processing,
account
it
and
is not
destination
going with
account.
any
User has to provide that
for
how much
processing.
amount
It
to
is not going with any
forwarded
current
and what
technology,
is the
right?
source account, what is the destination account. User
Yes,
interacts.
it is
But
going
batch
with an
application,
execution
user
model called as
non-interactive
MapReduce, and
applications.
currently we are
User
using
non-interactive
Spark.
applications.
Spark, very high speed processing technology, processing huge data in quick time.
User non-interactive
Yes.
applications, right? So Hadoop is meant for this user non-interactive applications. Here user is nowhere
So for
required.
storage HDFS and for
User is
processing
nowhere required.
MapReduce or Spark. Yes, drawbacks with the current databases. Drawbacks with the current databases. What limit?
User is nowhere
Okay.
required.
So if it, before I go with the drawbacks with the databases,
You may
here
ask
example,
why
if Hadoop is there for
railway
storing and
ticketing
processing,
PNR
what is the
status?
use of the current processing technologies and storage technologies? Already Hadoop can perform both storage and processing.
Railway ticketing
Why
PNR
again
status
this
currently
storage
our
and
status
processing
is
technologies?
200. After
You need
1
to
hour
clearly
it is
understand,
150.
right?
Tomorrow
Hadoop is for
morning it
batch
is 100. Tomorrow
applications.
evening it got confirmed.
Hadoop is for
Tomorrow evening it got confirmed, right?
batch
Yes.
applications.
Railway ticketing PNR status.
Hadoop is meant for batch application.
So this is happening. Here user is nowhere required. Here everything happening
Hadoop
in
is
the
meant for
background.
batch applications.
Most of these banking applications and financial applications are batch applications. And also like generating credit card statements for millions of customers. Hadoop is meant for batch statements. So there are two types of application. What do you mean by batch application? There are two types of applications. There are two types of applications. Customers. The first one, generating credit card statements online applications, railway ticketing PNR status. Second is like batch applications for millions.
What is the difference between these two?
Online applications and batch applications. Hadoop is not for online applications. Hadoop is meant for batch applications. Online applications. User interactive applications. User interactive applications. User interactive applications. Okay. So
Here
understood, right?
user
Online
gives the-
applications, batch applications. Hadoop is meant for batch
user gives
applications,
the
not for online
input.
applications. User
So
interactive
batch
applications,
applications,
here
here
user
user gives the
non-interactive
input.
applications. And here drawbacks with the current databases. Why Why databases are not used for storing Hadoop
User
data?
gives the input.
Drawbacks with the current databases. First thing is limited storage. Most of the databases very less storage, right? Limited storage or
Example,
less storage.
booking a movie ticket.
No parallel processing in most of the databases. No parallel processing in most of the
Booking a movie ticket.
databases. And as volume increasing, speed decreases.
Making
Here,
online
see that
transaction.
queries, right? For example, total amount from sales 10 records.
Making a
Total
online
amount from sales
transaction.
to 10 lakh records. Total amount from sales 10 crore records. Here, as volume increasing, from
Booking a
query
movie
to
ticket,
query, as
making
the
online
volume increasing,
transaction.
speed
Right.
decreasing, right?
So here
The
compulsory,
same way, if
the
complexity
user need
increasing,
to give
also
the
speed
input,
is
like
decreasing.
source
Here.
account and destination
Total amount
account.
from
User has
sales
to
fund 1
provide
lakh
that how much
records.
amount to be
Average amount from
forwarded
sales
and
fund
what is
1
the
1
source
lakh
account, what is the
records.
destination account.
Standard
User
deviation of amount 1 lakh
interacts.
records. But here,
But batch
query to query,
application, user
which
non-interactive
query executes faster?
applications.
Again, the first query.
User non-interactive
Second query is a
applications.
two-step process. First sum, next average to be calculated.
User non-interactive applications, right? So Hadoop is meant for this user non-interactive applications. Here, user is nowhere required. User is nowhere required. Complexity
User is
increases,
nowhere
speed
required.
decreases. Here, example, railway ticketing PNR status. Railway ticketing PNR status, currently our status is 200. After 1 hour, it is 150. Tomorrow morning, it is 100. Tomorrow evening, it got confirmed. Tomorrow evening, it got confirmed, right? Yes. Railway ticketing PNR status. If complexity increases,
So
speed
this is
decreases.
happening. So here,
Here
average amount
user
is
is
no
nowhere
step
required.
process as compared
Here
with the
everything
first
happening
query,
in the
second
background.
step. Takes
Most
lot
of
of
these
time,
banking applications and
financial
financial standard
applications or
deviation of
batch
amount from
applications.
sales. And also like
So
generating
standard
credit card
deviation of amount
statements
from sales one means
for millions of
as
customers.
compared to the first query and second query. The third query,
Credit card
standard
statements
deviation takes a lot of internal processing. It takes a lot of internal
for
processing.
millions
Right?
of customers. For millions of customers.
Databases can handle only structured data. They can handle only structured data. They cannot handle unstructured or semi-structured data. They can handle generating credit card statements for millions of customers.
Railway ticketing PNR status. That's generating credit card statements for millions of customers.
Databases can handle only structured data. They cannot handle unstructured or semi-structured data. Yes, these are the major drawbacks, right? Yes. Limited storage, no parallel processing. As volume increases, as speed decreases. Total amount from sales 1, total amount from sales 2, total amount from sales 3.
Okay.
There are
So
10
understood that
records,
online
there are 10 lakh
applications,
records,
batch
10 crore
applications,
records,
Hadoop is
so
meant for
volume
batch
increases,
application, not for
speed
online
decreasing.
applications.
Complexity increases,
So
speed
batch
decreases, can
applications,
handle
user
only
non-interactive
structured data.
applications. And here,
And coming to the
drawbacks with
Hadoop
the current
advantages.
databases.
Yes,
Why-
before I go to the Hadoop advantages,
Why
you need to know
databases are
something
not
about the
used
Hadoop
for storing
architecture.
Hadoop's data?
Drawbacks with the current databases. First thing is limited
Hadoop doesn't
storage.
follow. Hadoop
Most
doesn't
of the
follow
databases very less storage, right? Limited storage or less
client
storage.
server architecture. It won't follow
No
client
parallel
server
processing in
architecture.
most of the databases. No parallel processing in most of the databases. And as volume increasing, speed decreases. Here,
It won't
see that
follow
queries,
client
right?
server architecture.
For example, total amount from sales,
It
10
won't follow
records.
request
Total amount
response
from sales
architecture.
to
If you are
10 lakh
giving
records.
request, giving
Total
response,
amount
that
from
kind of
sales,
architecture
10
is not
crore
for Hadoop.
records. Here,
Hadoop follows master
as
slave
volume
architecture.
increasing, from query to query, as the volume increasing, speed
Hadoop
decreasing.
follows master slave architecture.
The same way, if complexity increasing, also speed is decreasing here. Total amount from sales 1 lakh records. Average amount from sales 1 lakh records. Standard deviation of amount 1 lakh
Master
records.
slave
But here,
architecture.
query to query, which query executes faster? Again, the first query. Second query is a two-step process. First sum, next average to be calculated. Hadoop follows master-slave architecture, single master, multiple slave. In this way, just observe this diagram, right?
Complexity increases,
So
speed
single
decreases.
master and multiple slaves architecture. So Hadoop, how Hadoop is able to accommodate unlimited data? How it is going to store unlimited data? Why not the other databases? Huge data storage, unlimited data storage, and huge data processing is possible in Hadoop.
If complexity
Single
increases, speed
master and
decreases.
multiple slaves.
So here average amount is a two-step process as compared with the first query. Second step takes a lot of time, right? And select standard deviation of amount from sales one. So standard deviation of amount from sales
slave
one
one, slave two,
as
so
compared
on,
to the
slave
first query
n.
and second query. The
This is
third
the
query
master.
standard deviation takes a lot of
Slave
internal
one, slave two,
processing.
and
It takes a
slave
lot
three.
of internal processing, right? F1.txt. Databases can handle only structured data.
F1.txt.
They can handle only structured data. They cannot handle unstructured or semi-structured
This
data.
F1.txt is
They can
divided
handle
into smaller parts. F1.txt, it is divided into smaller parts.
databases can
See,
handle only structured data.
Hadoop
They cannot
master,
handle
single
unstructured or
master,
semi-structured
multiple
data.
slaves.
Yes, these are the major
This we
drawbacks,
call it
right?
as
Yes.
a cluster.
Limited storage, no parallel processing. As volume increases, as speed decreases. Total amount from sales one, total amount from
Single
sales two,
master, multiple
total amount
slaves.
from
This we
sales
call it
three.
as a cluster.
Here 10 records, here 10
B1,
lakh records,
B2,
10 crore records,
B3.
right? So volume increases, speed
A file is
decreases,
divided. So here
complexity
each
increases, speed
system
decreases,
1
can
TB.
handle only structured data. And coming to the Hadoop advantages. Yes, before I go to the Hadoop advantages, you need to know something about the Hadoop architecture. Hadoop doesn't follow client server architecture. It won't follow client server architecture. It won't follow client server architecture. It won't follow request response architecture. If you are giving request, giving response, that kind of architecture is not for Hadoop. Hadoop follows master slave architecture. Hadoop follows master slave architecture. Master slave architecture. Hadoop follows master slave architecture, single master, multiple slave. In this way, just observe this diagram, right? So single master and multiple slaves architecture. So Hadoop, how Hadoop is able to accommodate unlimited data? How it is going to store unlimited data? Why not the other databases? Huge data storage, unlimited data storage, and huge data processing is possible in Hadoop. Single master and multiple slaves. Slave 1, slave 2, so on, slave n. This is the master. Slave 1, slave 2, and slave 3. Single master and multiple slaves. F1.txt. So here each system of 1 TB, 1 TB, 1 TB, 1 TB, and 1 TB. But here my file is
This
of 2 TB.
f1.txt is divided into smaller
This
parts.
file cannot be
f1.txt,
accommodated
it
in
is
any of
divided
this slave
into smaller parts.
because this 2 TB file cannot be stored in any of this S1 or S2 or S3. So it will be divided into smaller parts.
See, Hadoop
Smaller
master,
parts we call as
single master,
blocks.
multiple slaves.
So smaller parts,
This we
each
call
one
it
is
as
stored
a
in one
cluster.
system. Each one is stored in one system. File is divided into smaller parts. Each one is stored in one system
Single master,
and
multiple
processed
slaves. This we call it as
parallelly.
a cluster.
And processed parallelly.
B1.
So here
B2,
two advantages
B3.
you can see.
A file is
Huge
divided. So
data
here
sets
each
or
system
huge data
1
objects
TB.
can be stored, can be accommodated, even it's 2 TB or 3 TB or petabytes. So still, if you have got some 40 systems, your data is divided into partitions, and those are distributed across multiple systems and processed by multiple systems parallelly. You no need to take care about all this. It automatically takes care. Just you need to give what is the size of each block in that system. What is the size of each block that you need to give? Automatically divides and stores across. Two advantages: distributed storage and parallel processing. So your data is stored across multiple systems. Data is processed by multiple systems parallelly. B1 stored here, B2 here, B3 here. Executing the B1, nothing but a T1 task. Executing this B2, nothing but a T2 task. Executing this B3 is nothing but T3 task. T1 task assigned to system 1, T2 task executing this B2 is nothing but is assigned to system 2, T3 task is assigned to system 3. Means master is assigning a task to the slave. So slaves has to execute the tasks. It everything taken care by framework itself. You don't need to perform any of this. So master, what do you mean by a cluster? What do you mean by Hadoop cluster? What do you mean by a cluster? Group of nodes. Group of nodes. What do you mean by nodes? Nodes nothing but CPUs. Connected in a network. Connected in a network. Group of nodes, CPUs connected in a network. There are two types of nodes. There are two types of nodes. Master node, slave node. First is master node and second is like slave node. Master node, slave node. Master node responsibilities. Master node responsibilities. Master node responsibilities. Task assignment. Second is load balancing. Single master and multiple slaves. So here each system of 1 TB, 1 TB, 1 TB, 1 TB and 1 TB. Task assignment, load balancing. But here my file is of 2 TB. Master this file cannot be accommodated in any of this slave. Because this 2 TB file cannot be stored in any of this. So assigning tasks to the slaves, what are the tasks assigned should be equally assigned to all the slaves. So it will be divided into smaller parts. Fault tolerance. Smaller parts we call as blocks. Fault tolerance means so smaller parts. Each one is stored in one system. Multiple tasks. Each one is stored in one system. T1, T2, T3. File is divided into smaller parts. Slaves. Each one is stored in one system. Multiple tasks T1, T2, processed T3 assigned to multiple slaves. So and processed when they're executing parallelly, suddenly so if any two advantages you can see. Then the task of it has to be assigned to huge any of data the sets or huge data objects can be stored. So later I discuss in brief about it. Even it's 2 TB or 3 TB or petabytes. And so still if you have got some 40 systems, like health your data is divided into partitions and those are distributed across multiple systems and processed by multiple systems parallelly. You no need to take care about all this. It automatically takes care. Just health you need to give what is the size of each block in that system. Yes.
What is the size of each block that you need to give? Automatically divides and stores across. Slave node responsibilities. Two advantages: distributed storage and parallel processing. Data stored in the slaves, data stored across multiple systems. Data is processed by multiple systems parallelly. Data storage and data processing. B2 here, B3 here. Executing the B1, nothing but a T1 task. Executing this B2, nothing but a T2 task. Executing this B3 is nothing but T3 task. Data storage and data assigned to system 1, T2 task. So later I discuss in brief about this architecture, storage architecture and processing architecture. T3 storage architectural components and processing architectural components. Master is assigning a task to the slave. So slaves has to execute the tasks. It everything taken care by advantages. Unlimited data storage. Unlimited data storage because of what do you mean by cluster? What do you mean by scalability? Because of horizontally group of nodes. Horizontally unlimited group of nodes. What do you mean by nodes? Nodes nothing but CPUs. Connected in a network. Unlimited scalability. Connected in a network. Very high speed processing. Horizontally unlimited scalability, and second group of nodes, CPUs. Unlimited data storage is possible because of unlimited scalability. Because observe this, there are two types of nodes. If you're running a business with less number of slaves, for example, with only 3 systems or 10 systems, master node, slave. You're running a small business with 10 systems. And second is like slave node. S1, S2, so on up to S10. Master node, S1, S2, so on up to S10. Master node responsibilities. So your business has increased, your branches have increased, your customers have increased, your data has increased. Similarly, your systems also should keep on increasing horizontally. Second is load balancing, unlimited scalability. Horizontally, unlimited number of slaves to be added. Horizontally, unlimited number of slaves, right? Task assignment, load balancing, master node responsibility, task assignment, load balancing. Horizontally unlimited scalability. So assigning tasks to the very slaves, high speed what are the tasks assigned to be equally assigned to all the slaves because of parallel processing. Fault tolerance. Fault tolerance means observe. If multiple very high speed processing because of multiple tasks T1, if you observe parallel and non-parallel assigned to multiple non-parallel and parallel. See multiple tasks T1, T2, T3 assigned to multiple slaves. So and parallel, when they're executing parallelly, suddenly if any one system is down, then the task of it has to be assigned to any of the other slave. That is called fault tolerance. So later I discuss in brief about it. And health monitoring. Next is like health monitoring. Non-parallel and parallel. Health for example, monitoring. One person preparing one item, taking 1 minute. Task assignment, load same one person preparing 10 items, health monitoring takes 10 minutes. The same one person preparing 100 items takes 100 minutes. But in the case of parallel process, slave node responsible. One item, 1 minute. 10 items also 1 minute. Data stored in the slaves, data processed in the slaves. Slave node responsibility. Data storage and data processing. Okay. In parallel pro. One item 1 minute, data 10 items process. 1 minute, 100 items also 1 minute. Data storage and data processing, right? Yes. So later I discuss in brief about this architecture, storage architecture and processing architecture. Storage architectural components and processing architectural components. Okay. Understood. Here we are saying about persons, but in our time not Hadoop advantages. Unlimited data storage here. Unlimited data storage because of systems running parallelly. Horizontally unlimited scalability because of can handle all varieties of data, structured, unstructured, and semi-structured data. Scalability. Hadoop is an open source. No licensing is required. Hadoop is an open source, no licensing is required, right? Yes, most of the Hadoop products are from
unlimited
Apache.
scalability.
You can take it
Very
from
high
Apache
speed
site,
processing,
Apache mirrors the site.
horizontally unlimited scalability, and
Yes.
second is
Okay, commodity
unlimited
hardware.
data
Commodity
storage is
hardware
possible
means
because
Hadoop
of
can run on any
unlimited
hardware. It doesn't mean
scalability,
that you need to
because
have the
observe
highly
this.
configured systems. It can run on any hardware systems. So these are the Hadoop advantages.
If you're running a business
Unlimited
with
data
less number of
storage,
slaves, for example,
high-speed
with
processing,
only 3
can
systems
handle
or 10
all
systems.
varieties of data.
You're running a small
Structured and
business with 10
semi-structured,
systems,
right?
S1, S2, so
Open
on up to
source
S10,
and commodity hardware.
S1, S2, so on up to S10. So your business has increased. Yahoo, it has branches have increased. There are many tests done, right? Your data has many tests done similarly to check the speed of Hadoop as compared with other things, right? Yahoo has horizontally taking a table of 100 TB consisting of unlimited number of slaves to be added. Task is sorting based on 16 columns, right? Time taken, right, by Oracle to process this, right? 100 TB data sorting based on 16 columns. It has taken nearly 3.5 days. Yes. Teradata, it has taken nearly 4.5 horizontally unlimited. Sorry, MySQL has taken 6 Very
days.
high speed
Oracle
processing
3.5 days.
parallel
But
processing.
specialized databases
Because
like
of parallel
Teradata,
processing, right?
which are used for data warehouse, taken just 4.5 hours. Netija, another specialized database used for data warehouse.
Very high speed processing because of
just
parallel
3
processing.
hours taken just
If you
3
observe
hours.
parallel and
Finally,
non-parallel,
Hadoop.
talk about
Hadoop has
non-parallel
taken
and parallel.
3.4 minutes. Hadoop has just taken 3.4 minutes. The latest version of Hadoop has just taken 1.2 minutes. This is the speed of Hadoop as compared with the other things, right? This is the speed of Hadoop as compared with the other databases. Okay, not only processing point of view. For example, one person storage point preparing one item taking 1 minute. Hadoop has also proven the same one person preparing a 10 items takes 10 minutes. Why databases like Oracle, the same one person preparing 100 items takes 100 minutes. But in the case of parallel processing, one item 1 minute, databases 10 items also 1 minute, databases like Hadoop, 100 items also 1 minute. Why databases like Hadoop? No, sorry, databases like Oracle. Okay. Won't support 1 item 1 minute, 10 items 1 minute, support unlimited, won't support unlimited storage. So if we talk for Oracle in the real time, you can go with multiple systems. Means here databases, okay, and the max limit on the number of slaves. Max limit, understood? Here we are saying about persons, number of slave systems. Here, number of slave systems. 10 systems, 100 systems running parallelly. 1 minute. First one, databases and max can handle all varieties of data, structured, unstructured, and semi-structured data. It can go with the maximum. Hadoop is an open source, no licensing is required. Hadoop is an open source, no licensing is required, right? Yes, most of the Hadoop products are from Apache. Max beyond that, take it from Apache site. Even MySQL site. Even MySQL, right? Maximum it can go with. It can go with only hardware. Commodity hardware means it can go only can run on any hardware. It doesn't mean that you need to have and the highly configured systems. It can run on any hardware systems. MySQL Express. So these are the Hadoop advantages. Unlimited data storage, high speed processing, can handle all varieties of data. So structured, unstructured, and semi-structured, SQL server, right. Open source SQL server and commodity hardware. It can go with the maximum 256 nodes. And Oracle, MySQL Express, Yahoo, SQL Server, table. And DB2. There are many tests done, right? There are many tests done to check the speed of Hadoop as compared with other things, right? Yahoo has conducted a test. Oracle taking a table of 100 TB consisting of 1024 columns. Task is sorting based on 16 columns. Time taken, right? By Oracle to process this, right? 100 TB data sorting based on 16 columns. It has taken nearly 3.5 days. Teradata, it has taken nearly 4.5 hours, right? Sorry. MySQL has taken 6 days.
All these
Oracle
databases
3.5
can go
days.
with
But
maximum
specialized
256
databases
nodes.
like Teradata,
Beyond that, it
which are
cannot
used for
support.
data
Even
warehouse, taken
databases
just
like
4.5
Oracle.
hours.
For example,
Netija,
even if
another
256 nodes
specialized
are database used for data warehouse,
means just like your
used
mobile phone.
just
If we
3
take a
hours,
labor
taken just
example,
3
just
hours.
like your mobile
Finally,
phone, if
Hadoop.
it is given 64
Hadoop has
GB
taken
internal storage,
3.4
if all the
minutes.
64 GB if you
Hadoop
have
has
filled
just
it,
taken 3.4 minutes. The
then
latest
the
version
performance of the
Hadoop
phone
has just
degrades. In
taken
the same way here, if all the
1.2
256
minutes.
nodes utilized, the performance
This is
of
the
the
speed of
system
Hadoop as
degrades.
compared with the
Sometimes it won't even start.
This is the
And talk about the
speed of
specialized
Hadoop as
databases
compared
like
with the
Teradata.
other
To go with
databases.
database like Teradata, it can go with the maximum 512 nodes.
Okay, not only
512
processing point
nodes.
of
Currently,
view,
it is
Hadoop
going
has
with
proven in the
1024,
market.
right?
Storage point of view also, right?
1024
In
nodes
the
are
also see,
systems.
Hadoop has also proven storage
Next
point
is
of view. Here I got a query.
Netija. Why databases like Oracle won't support
going with
unlimited
512
storage?
nodes.
512 nodes. Yes. Why currently it is going with
Databases.
1024? 1024
Why databases
nodes
like Hadoop
and Vertica.
Why databases like Hadoop
Vertica also going with 512 nodes. No, sorry, databases like Oracle 512 nodes won't support. Yes. So none of these
won't
databases
support
are
unlimited,
unlimited, won't
databases are
support
handling
unlimited
data,
storage.
not pass. Once this data 1000 nodes gets filled, they
So
cannot
if we
support
talk
data
for
further.
Oracle in the
But
real
there
time,
is no
it can go
limit.
with multiple systems. Means here databases,
But there is no limit
and the
on
max
the
limit
number
on the
of
number of
slaves.
slaves. Max limit
There is no
on
limit.
the number of slave systems.
There is no limit on the number of slaves that Hadoop can
Number
have.
of slave systems. First one, databases and max limit on the number of slave systems. Database like Oracle, it can go with a maximum.
But there is no limit on the number of slaves that
256
Hadoop can
nodes are
have.
systems. 256 nodes. Max, beyond that, it cannot support. Even MySQL, right? Maximum it can go with. It can go with only 54.
No limit on the number
can
of
go only
slaves
with
that
54
Hadoop can have.
systems.
It can go with unlimited
And
number of slaves.
MySQL Express is there. MySQL Express. It can go with the 256
Yahoo
nodes.
when first time implemented Hadoop.
So, and if you talk about SQL Server, it can go with the maximum 256
Went
nodes.
with 4,000 slaves for storing its data.
And Oracle,
4,000 nodes
MySQL
storing
Express,
its
SQL
data.
Server,
Currently
and
it is going
DB2.
with currently
DB2
Yahoo
means
going with
256 nodes. Oracle,
MySQL Express, SQL Server, 12,000 nodes. DB2. Facebook when first time implemented Hadoop. Went with 8,000
all these
8,000
databases
nodes for
can go
storing
with
its data.
maximum 256
Currently
nodes.
beyond that it cannot support. Even databases like Oracle, for example, even if 256 nodes are used,
means just like
it's
your
going
mobile
with
phone. If I take a labor example, just like your mobile phone, if it is given 64 GB internal
52,000
storage,
nodes for storing
if all
its
the
data.
64 GB if you have filled it, then the
So
performance
there
of
is
the
no
phone
limit on the
degrades.
number
In the
of
same way here,
systems
if
that
all the
Hadoop can
256
have,
nodes
right?
utilized,
Unlimited, right?
the performance of the system degrades.
5,000 or
Sometimes it
5,000
won't
or
even start.
10,000 or 50,000, right?
And
There is no, right?
talk about the specialized
So Hadoop
databases
is
like
proven in the
Teradata.
market,
To
storage
go with
point of
specialized
view,
database
processing
like
point of
Teradata,
view,
it can go with the
with
maximum
unlimited data
512
storage
nodes.
and very high speed processing.
512 nodes.
Just
Currently,
now I
it is going with
discussed, right? The speed
1024,
wise
right?
also, like with it has
1024
taken days
nodes
of
are
time,
systems.
and this has taken hours of
Next
time, but
is
Hadoop has taken minutes of time.
Netija.
So just I was briefing you, right? Even like what
It's
is
going with
Spark,
512 nodes,
PySpark, need for
512
PySpark,
nodes. a real life usage of PySpark,
Yes.
PySpark job market.
Currently, it is going
This
with
is so
1024.
Apache Spark is an
1024
open source
nodes
distributed cluster
and
computing
Vertica.
framework introduced by Apache Software Foundation.
Vertica
It is a general engine
also
for
going
big
with
data
512
analysis,
nodes.
processing, and computation, right?
512 nodes.
And why PySpark? It is a
Yes.
Python API.
So none of these databases are
Spark.
specialized databases are
PySpark is a
handling
Python API
unlimited
to use
data,
Spark.
not pass. Once this data 1000
So
nodes
I
gets
said
filled,
it
they
is
cannot support data further.
cluster computing.
But there is no limit.
System which is used for big data solution. It's a lightning fast technology that is designed
But there
for
is no
fast
limit
computation.
on the number of
Open
slaves.
source. It is a
There is no limit.
PySpark is used for running a distributed SQL.
There is no limit on the number of slaves
PySpark
that
used
Hadoop
for
can
running
have.
creating data pipelines for ingesting data into databases. Also used for running ML algorithms. Also working with graph algorithms for data streams and many and need for
But there is no
PySpark.
limit on the number of
huge
slaves
data
that
is
Hadoop
getting
can have.
generated. So this data contains of hidden patterns, unknown corrections, user preferences, market trends, and other useful information. So you need to extract that valuable information from the
No
raw
limit
data.
on the number of slaves
So
that Hadoop can have. It
we
can
need
go
to
with
have some
unlimited
efficient tools to
number of
perform this kind
slaves.
of operations for huge data. So we need some scalable and flexible tools to crack this, right?
Yahoo, when first
and
time
gain
implemented
benefit from
Hadoop.
this. So
Yahoo,
PySpark
when
is
first
such
time
a kind.
implemented Hadoop.
So combining a Python and Spark will be the efficient way for the world of big data. That's why Apache Spark community came up with a tool
4,000
called
slaves for
PySpark,
storing its data.
Python
4,000 nodes for storing its data.
Python API for
Currently,
Spark.
it is going with
real life usage of PySpark.
Currently,
That is
Yahoo
used in the
going with
commercial sector. PySpark is used in the commercial sector, right? Apache Spark, a real-time processing. Banks and other financial fields,
12,000
they're using
nodes.
Spark, PySpark to retrieve the customer's social media profile and analyzing,
Facebook,
gaining
when first time
insights,
implemented
which
Hadoop.
helps in taking the
Facebook,
right
when
decisions.
first time implemented Hadoop.
And in credit risk assessments and fraud detections, it is used. In healthcare, analyzing the patient's
When
who is going to face the issue based on this records.
8,000 nodes for
And
storing
even
its data.
entertainment industry like
Currently
Netflix using
Facebook going with
PySpark. The popular OTT platform like Netflix using Spark, right? Real-time processing.
It's going with
Personalized online movies or web series. It is going to process nearly 450 billion
52,000
events
nodes for
per day,
storing its data.
streamed over server-side applications. So there is no
And
limit
also
on the
like
number of systems that Hadoop can have,
e-commerce,
right?
Unlimited,
Websites
right?
like Flipkart, Amazon,
5,000 or
all
5,000 or 10,000
Amazon,
or
Flipkart are
50,000,
using
right?
Apache
There is
Spark
right?
for
Yes.
advertising. So Hadoop is proven
to
in the
enhance the
market,
customer
storage point of
experience,
view,
right?
processing point
Even
of
in the
view,
tourism
with
industry to
unlimited
advise
data
millions
storage
of
and very
customers
high
in this
speed
today.
processing. PySpark is
Just now I
mostly
discussed,
used,
right?
and even
The
PySpark has
speed-wise
got a great
also,
demand.
like with it has
See the
taken
job
days of
market for
time,
it, right?
and this has
Because
taken
of its
hours
very
of
high
time, but
speed,
Hadoop has
huge
taken
data
minutes of time.
processing at a very
So
quick
just I
rate
was
of
briefing you,
speed.
right? Even like
If you see in
what
the
is
previous day, I have
Spark,
shown one example.
PySpark, need for PySpark,
PySpark,
a
very
real
high
life
speed
usage of
technology,
PySpark,
right?
PySpark job
And
market.
if you see
This
the
is
salary package for
so
this
Apache
also like
Spark
2 times more than the
is
other
an open source
technologies,
distributed
or
cluster
1.5 times
computing
more than the other
framework
technologies. You can
introduced
compare
by
that
Apache
salary
Software
packages, right?
Foundation. It is
So
a
the same
general
way they'll be
engine for big
expecting the
data
skills from you,
analysis,
the technical skills of
processing,
this
and
PySpark.
computation.
So
Right?
everything will be
And
discussing
why
from the ground
PySpark?
level to advanced level with many
It is a
working
Python API
examples. You see
to
that
use a
course content
Spark.
for it.
PySpark is a
So
Python API to use a Spark.
this is the
So I
course
said
content,
it is
big data Hadoop. What is big
cluster
data? Need for
computing
Hadoop
system which is used for
RDBMS,
big data
advantage of Hadoop,
solution.
Hadoop
It's a lightning
ecosystem
fast
components,
technology
HDFS,
that is designed for
Hadoop
fast
distributed
computation.
file system,
It's an
and map
open
reduce
source
entire map
It is
reduce in brief.
and
Scoop SQL
PySpark
plus
is used for
Hadoop.
running a distributed SQL.
The first two characters and the
PySpark used
last
for
three
running
characters
creating a data
SQL plus Hadoop
pipelines for
for import
ingesting
and
data
export
into
operations,
databases. Also
exporting
used for
from
running
HBase
ML
to
algorithms.
importing
Also
and exporting, and
working with
also
graph
transformations,
algorithms
filtering and
for
grouping,
data
merging, right?
streams
Yet another resource
and
negotiator
need for PySpark.
and
So huge
speculative
data is getting
execution,
generated.
speculative job,
So
and
this data
speculative
contains
task.
of hidden patterns,
Yarn
unknown
components, yarn
corrections,
architecture. how the
user
processing is happening,
preferences, market
and I'll be
preferences,
discussing
and
one
other useful
NoSQL database
information.
also.
So you need to
So
extract
three
that
processing
valuable
components I'll be
information from
discussing.
the raw data.
One storage
So
component like
so we need to have
HDFS,
some
one
efficient tools
NoSQL
to
database
perform
like
these kind of
HBase,
operations for
and one
huge
streaming
data.
component like Kafka I'll be
So we need some
discussing as part
scalable
of
and
this course,
flexible
right?
tools to crack this, right? Data and gain
And a
benefit
NoSQL
from this.
database
So
like
PySpark
HBase,
is
Hadoop's
such a
database,
kind.
and how to
So
perform CRUD
combining your
operations,
Python and
creating tables,
Spark
reading,
will be
inserting,
the
update, delete,
efficient way for
and
the world of
integrations with
big
Hive
data. That's why
and its
Apache
architecture.
Spark
Hive, one of the
community
important
came
component
up
of
with a
Hadoop.
tool
Only you
called
can see jobs in
PySpark,
Hive, right? You can see a
Python
lot of jobs for
plus
only in Hive
Spark,
component. In Hadoop,
Python
Hive is there.
API for
You
Spark.
can see just
Real life
type
usage
Hive
of
jobs, we say.
PySpark.
Just
So
say
it is
Hive
used in
jobs.
the commercial sector.
You can
PySpark
see a
is
lot
used
of
in the
jobs.
commercial sector like Apache Spark,
11,490 Hive job
a
vacancies
real-time
in December
processing.
2024.
Banks and other
Hive
financial fields, they're
11,490
using Spark,
only on
PySpark to
Hive. If you know
retrieve the
that
customer
knowledge on this Hive, right?
social media profile and analyzing, gaining insights, which helps in taking the
Candidate
right
Hive, right?
decisions.
And then big
Credit
data,
risk
Hadoop and Hive.
assessments,
Big
and
data
fraud
engineer,
detections,
data
it
engineer,
is
right?
used
Big data, Hive,
in
Spark,
healthcare,
Speed,
analyzing
right?
the
This one.
patients and who is going to face that issue based on
Big
these
data, Hadoop,
records.
right?
And even entertainment industry like Netflix using
Yes, lot
PySpark.
of jobs for this.
The popular OTT platform like Netflix using Spark, right? Real-time processing, personalized
coming back to
online
this.
movies or web series.
So only with that way we'll
It
be
is going to
discussing in
process
brief
nearly
about Hive
450 billion
architecture, its
events per
metastore.
day. It's like just
Streamed
like
over
SQL.
server-side applications.
HQL is there, HQL Hive query language, difference between HQL and SQL.
also like e-commerce,
90% they are same, but 10%
e-commerce
you see where it can handle
websites like
unstructured,
Flipkart,
semi-structured
Amazon,
data.
all these
Built-in
Apaches
functions you can see
Amazon,
loading data
Flipkart are using
from
Apache
files,
Spark
Hive tables
for
from
advertising.
HDFS files.
And to
Internal
enhance
tables,
the
external
customer
tables, working with
experience,
unstructured, working with
even in the
XML
tourism
data, working
industry
Hive,
to advise
working with
millions of
JSON data,
customers.
URL,
This way,
weblog
today,
data,
PySpark
unions,
is mostly
UDF,
used, and
UDF,
even
UDTF,
PySpark has got a
partition
great
table,
demand.
performance
This is
tuning
the job market for
mechanism,
it, right?
partitioning,
Because
indexing,
of its very high
bucketing,
speed, huge
and
data
indexing in
processing
Hive,
at a
right?
very quick rate
And
of
coming to
speed.
this PySpark.
If you see in the
PySpark
previously, I
very
have
high
shown one
speed
example.
processing, which has great boom today.
PySpark
In
very
this,
high
right,
speed
PySpark
technology,
introduction,
right?
need for PySpark.
And if you
PySpark
see the
OTT
salary package for
computations,
this also like 2 times more than the other
persistence options,
technologies,
PySpark
or
core
1.5
computing,
times more than the other
groupings and
technologies. You can
aggregations,
compare
single
that
grouping,
salary
multi-grouping,
packages, right?
multiple aggregations,
In the
various
same way, they'll be
functions and
expecting the
transformations,
skills from you, the
union,
technical skills
distinct,
of this
sort by
PySpark.
key, count
So
by
everything
value,
will be
count by key,
discussing from the ground level
SQ
to advanced
PySpark
level with
SQL
many
data
working
frame, data
examples.
frame API.
You see that
So
course content for
creating
it.
data frame, empty data frame,
So
struct type, struct field, row class, column class, select,
this is the
collect which
course
column,
content,
where,
big
filter,
data,
draw.
Hadoop, what is
All
big
these are the
data,
built-in
need for
functions
Hadoop,
with
some
many working
RDBMS,
examples,
advantage of
PySpark
Hadoop,
SQL
Hadoop
functions,
ecosystem
aggregate
components,
functions,
HDFS,
PySpark built-in
Hadoop
functions, all
distributed
this
file system, and
external
map
sources,
reduce, entire map reduce in brief.
deployment modes, PySpark
Scoop,
applications,
SQL
TLP
plus
task,
Hadoop.
driver and executor, building
The
Spark
first two
applications.
characters and the last
So
three
PySpark
characters,
streaming
SQL
concept,
plus
integration
Hadoop.
with Kafka and
For
ML.
import and export
Apart from
operations,
this, even Python, you
exporting
need to have
information
some
based
knowledge
to
on this
okay.
So
Importing and
Python
exporting, and
basics,
also
Python
transformations, filtering
operations,
and grouping, matching, right?
operators,
Yet another
IDs in
resource
Python, flow
negotiator,
control statements, looping
and
statements,
speculative
strings,
execution,
collections,
speculative job, and
lists,
speculative task.
tuples,
Yarn
sets,
components, yarn
dictionaries,
architecture, how the processing is happening.
functions in
And I'll be
Python,
discussing one NoSQL
and
database also.
modules in
So three
Python,
processing
modular
components I'll
programming
be
packages
discussing.
in Python, errors and
One storage
exceptions in
component
Python,
like HDFS,
file handling,
one NoSQL
object-oriented
database like
programming
HBase,
concepts,
and one streaming
regular
component like
expressions,
Kafka
how
I'll
to
be
extract
discussing as
required
part of
data
this
from the
course, right?
given data, database connectivity, how to connect with the
And the
database, how to
NoSQL database like
I'll show you the
HBase,
installation
Hadoop's
of one
database,
database,
and
Python
how to
datetime,
perform CRUD operations,
operating system
creating
dated,
tables, reading,
iterators,
inserting, update,
generators,
delete,
closures, decorators,
and
web scraping,
integrations with
graphic
Hive
module like Excel,
and its
working with
architecture.
Excel, data
Hive,
analytics,
one of the
introduction to
important
data
component of
science,
Hadoop.
Python
Only you can see
pandas
jobs
module
in
in brief,
Hive, right? You can see a
NumPy
lot of
numerical
jobs for
Python
only
in
in
brief,
Hive component.
matplotlib for
In
plotting
Hadoop, Hive
visualizations,
is there.
generating graphs.
You can see just
So all this in brief,
type
right?
Hive jobs.
Yes.
You say.
So I was
Just say
just saying,
Hive jobs.
so in this course, you'll be
You
learning
can see a lot
mainly
of jobs.
for technologies like Hadoop,
11,490 Hive job
PySpark,
vacancies in December
Linux, and Python.
2024.
So
Hive
Python nearly 50 sessions you'll be
11,490
having. Just now I showed you
only
like
on
how
Hive. If
briefly.
you know that
So
knowledge on
both
this
Python
Hive,
core
right?
and advanced will be
Yes.
discussed. Monday to Friday you'll have class for this Python. You can attend any of my Python
Candidate
batch.
Hive, right? Yes. So So tomorrow, Monday at 8 o'clock, there is a
Big
Python
data,
batch.
Hadoop and Hive.
And this
Big
coming
data
Thursday,
engineering,
if you
data
want
engineering,
evening
like
batch,
big
there is
data,
8
Hive,
p.m.
Spark,
There is a
Spoofer.
Python
Right?
batch
This
going
one.
to start. Monday tomorrow is at 8 a.m. And these three things will be on Saturdays and Sundays. 2 hours on Saturday and 2 hours on Sunday. It goes for 12 weekends in brief jobs for this. 15,000 is the course fee for all this, right? Yes. Any queries from your side? No. So as I said, said by the Durga software, you can see a big message in the that way we'll be Zoom chart brief about Hive architecture. The big message is given in the Zoom chart, just like SQL. SQL is link will be changing. Hive query language difference between HQL and SQL. 90% they are same, but 10% you see where it can handle unstructured, semi-structured data. Built-in functions, you can see loading data from files, Hive tables from HDFS files. Internal tables, external tables, working with unstructured, working with XML data, working Hive, working with JSON data, URL weblog data, unions, UDF, UDAF, UDTFs, partition table, performance tuning mechanism, partitioning, indexing, bucketing, and indexing in Hive, videos to your Google. And coming to the PySpark notes, soft copy of very high speed processing, which has great provided. A WhatsApp group for technical discussions, or if you get any errors, you can take snap of it and post in the group. Interview questions, assignments and tasks to work with, right? Core computing, all this. Groupings and aggregation, the videos single Google, multi-grouping, multiple aggregations, various and will be added and transformations. Will be added to the union, distinct, sort by key, every day, count by value, count by key. Every session videos will be getting data frame, API. Through that. So creating data frame, empty data frame, and attend the next session for the better understanding. Any queries from your side? Collect with column, where, filter. Any queries from all these are the built-in functions with many working examples, PySpark SQL functions, aggregate functions,
regarding the
PySpark built-in functions, all this.
What type of preparation need to be from our side? Like what type of device or machine need to be prepared for this? Or there will be remote
applications. So PySpark for streaming concept integration, I'll be providing you like a apart from this, even Python, you need to have some knowledge on this to download. So I'll be forwarding to your Google Drive, and I'll be just guiding you. I'll be demonstrating you how to work with it, how to use it. No need of any so just whatever system you have collections, lists, that's fine. Tuples, so basics of SQL required. Functions in Python and Linux anyhow I'll be discussing, and Python modules in Python, modular programming packages in Python, errors and exceptions in Python. File handling, object-oriented programming concepts, anyhow Python and regular expressions, how to extract required data from the given data, database connectivity, how to connect with the database. So don't worry about. I'll show you the installation of one database, Python, datetime.
No, I mean for the hardware itself, is there a
generators,
specific
process,
requirement
decorators, web
for the
scraping,
laptops?
RAM like minimum 8 GB if it is fine. If it is to data science, Python, Pandas module in brief, NumPy, numerical Python in brief, minimum 8 GB RAM required. If you have got less than that also, but the only thing is the speed will be less. All this in brief, right?
Okay.
Whenever you type any command, so in this course you'll be learning very slow. You are getting the response. Technologies like HADOOP, PySpark, Linux, and Python.
And how long?
So Python nearly 50 sessions will be having. Just now I showed you right how briefly. So both Python core and advanced will be discussed.
For me,
Monday to Friday
you'll
have class for this Python. So next you can attend any of my Python batch. 5 to 7. So tomorrow Monday at 8 o'clock there is a Python.
5 to 7.
5 to 7, right? And 2 hours coming Thursday at 8 if you want evening batch. And 8 p.m. Python will whatever you are attending. Python batch morning batch or evening batch. Monday tomorrow is at 8 a.m. And these three things will be on Saturdays and Sundays. Python sessions 2 hours on Saturday and 2 hours on Sunday. Either 12 weekends in brief from Monday to Friday morning or evening. 15,000 is the cost for the videos of it. And this will be in the weekend from your side 2 hours on Saturday. So as I said by the Durga software, will be extending the message in the Zoom chart.
And for the Python as well,
The big message is given in the Zoom chart, right? So all this link will be changing. All these are live sessions.
I mean, yes, but because I'm just joining from different time zone and different even weekdays and weekend days. That's why I'm asking mainly about if I missed any session, there will be recorded even for
next Saturday. So you are
Linux
supposed to
or
get
for
enrolled
Python or for every
for getting
part of this
everything
training.
for all these things starting with the recordings, right? Immediately
Okay.
I'll be demonstrating about the software, the session recording you'll be getting, right? So get enrolled.
Great. Thank you.
You'll be getting the videos to your Google Drive. Okay. notes, soft copy of the
So
notes, clear
if I'm
soft
done with
copy
your
of the notes will be
queries, then I'm
provided.
signing off
A
for now.
WhatsApp
Meet you on
group
next
for
Saturday,
technical
starting with
discussions,
this
or if you get
Hadoop, right?
any errors, you
When
can
Hadoop
take
is
snap of
going,
it
right,
and
we
post in
will
the
be
group.
learning Python in the
Interview
weekdays.
questions, assignments,
So
and
by the
tasks to
time this
work
Hadoop
with, right?
completes, this Python
All
core
this.
gets
So you'll be
completed.
getting
When
the
we
videos
start
to
with
your Google
PySpark,
Drive,
Python
notes to
Advanced
your
will be
mail
started.
address,
Both will be
and
running
you'll be
parallel.
added next Saturday. You'll be
Before
added
that,
to the
before I start with
WhatsApp
this, right,
groups. Every
I'll be
day,
also
one
demonstrating about the
every
Linux
session,
commands.
videos you'll be getting.
Fine.
If you miss any
Okay.
sessions, you can
Thank you
go
all for
through
your
that
time. Thank you. Meet you on
videos
next
and
Saturday.
check,
Get
right,
enrolled for
and
getting
attend the
all
next
these
session
things,
for the better
videos,
understanding.
notes,
Any
and
queries
getting
from your
added to the
side, right?
WhatsApp, right? Yes. Thank you all.
Any
Bye.
queries from your side, anyone?
Hello.
Yes, go ahead.
Yes. Regarding the practical and labs, what type of preparation need to be from our side? Like what type of device or machine need to be prepared for this? Or there will
So,
be remote access lab?
so for that practicals, right, I'll be providing you like a FIGB soft, like what you need to download. I'll be forwarding to your Google Drive, and I'll be just guiding you. I'll be demonstrating you how to work with it, how to use it. No need of any, so just whatever system you have got, that's fine. So
Okay.
basics of SQL required, and Linux anyhow I'll be discussing, and Python also will be discussed. So those are the prerequisites, right? Linux, as basic SQL and Python are the prerequisites. Anyhow, Python and Linux I'll be discussing, and basic SQL also wherever required I'll be just demonstrating, right? So don't worry
Oh,
about the software. Just I'll be providing you the things.
no, I
Yeah.
mean for the hardware itself, is there a specific requirement for the laptops or
So
something to
if
be?
RAM like minimum 8 GB, if it is fine, if it is there, it's fine. Remaining everything, right? If you have got a good
Okay.
RAM, okay. If you have got a minimum 8 GB RAM required, if you have got less than that also, but the only thing is the speed will be less.
Okay.
Whenever you
Okay.
type
Fine.
any whenever you type any command, very fast or very slow, you are getting the response. Depends upon your RAM capacity.
Okay.
What is
And
your
how long the session is going to be for the next weeks? Because here I'm asking because for me Sunday is a working day.
So next week,
I
right?
just
Saturday, so 5 to 7, right? 5
5 to 7.
5 to 7, right? 2 hours and 2 hours on Saturday, 2 hours
Well,
on Sunday. And this Python, whatever you are attending, either you can choose morning batch or evening batch for Python.
okay.
It will be from Monday to Friday. It will be Python sessions. You need to attend this either weekdays from Monday to Friday, morning or evening, or going through the videos of it. And this will be in the weekends, 2 hours on Saturday, 2 hours on Sunday. Sometimes we'll be extending when we start with the practicals. Right?
And for the Python as well, there will be recordings, correct?
So
You
all
can,
these are live sessions. All these are live sessions.
I mean, yes, but because I'm just joining from different time zone and different even weekend days, weekdays and weekend days. That's why I'm asking mainly about if I missed any session, there will be recording even for Linux or for Python or for every part of this
Everything
training, correct?
for all these things, you'll be getting the recordings, right? Immediately
Okay,
the session completes, the session recording you'll be getting, right?
great. Thank
For
you.
all this. Okay.
Thanks.
Okay. So if I'm done with your queries, then I'm signing off for now. Meet you on next Saturday, starting with this Hadoop, right? When Hadoop is going, right, you will be learning Python in the weekdays. So by the time this Hadoop completes, this Python core gets completed. When we start with PySpark, Python Advanced will be started. Both will be running parallel. Right? Before that, before I start with this, right, I'll be also demonstrating about the Linux commands, right? Fine. Okay. Thank you all for your time. Thank you. Meet you on next Saturday. Get enrolled for getting all these things, videos, notes, and getting added to the WhatsApp, right? Yes. Thank you all. Bye. Yeah. 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 Good evening, all. So myself, I'm
like I hold 20 plus years of experience, which includes nearly 10 plus years of experience in Hadoop and Spark environment. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not, right? Okay. So as part of today, I'll be yes. Thank you. Yeah. As part of today's exam, I'll be covering the following things. So what is big data? What is a big data? Why Hadoop? Why Hadoop? Drawbacks with the current databases. Drawbacks with the current databases. Drawbacks with the current databases. Hadoop and Spark. Hadoop and PySpark. Advantages. Hadoop and PySpark. Job market. So yes, starting with big data, the name itself saying like huge volumes of data. Currently, the data is getting stored. How the data storage units like KBs of data, MBs of data, GBs of data, gigabytes, terabytes. Beyond that, we have got petabytes, exabytes, zettabytes, etabytes, sotabytes, so on. KBs of data, MBs of data, GBs, TBs, petabytes, exabytes, zettabyte, etabytes, sotabytes. You should have seen KBs of data, MBs of data, GBs of data, even TBs of data. But beyond that, today data is getting generated in petabytes, right? 1 petabyte equal to 1024 TBs. Already 1 TB is a large storage unit. Examples of petabytes of data generation. Examples of petabytes of data generation. Take example of a banking sector. If you take example of a SBI bank, within the city, we see hundreds of branches for SBI. Within the entire state, we see thousands of branches for SBI. Within the entire country, lakhs of branches for SBI, right? Again, with each branch, millions and millions of customers. Each customer making multiple transactions per hour, per day, per week, per month, and year. Each and every transaction has to be stored, right? Huge data is getting generated. Forget about this. You are aware about social media like Facebook. For Facebook, millions and trillions of users. Not only within the country, entire world. In a minute, how many posts and videos are getting circulated? It has to store each and every post and video, right? What is the data generated by Facebook in a minute, in a hour, in a day, in a week? So huge data is getting generated, right? Not only like Facebook, today, most of the applications are generating data in petabytes. If we talk about any application, for example, If I take 1 minute transaction, if I take 1 minute transaction, how many Facebook posts? What is the data generated by Facebook in a minute? What is the data generated by Twitter in a minute? Keeps on generating, right? And what is the data generated by Google? Google queries. Today, everyone are querying in the Google, right? What is the data generated by Google in 1 minute? And everyone, you are uploading the videos in the YouTube. YouTube videos upload. What should be the storage capacity to store all the videos? And millions and trillions of users. Email messages. Millions and trillions of messages need to be stored, right? And just now I was talking about bank transactions. Bank transactions. Or if we talk about the telecom transactions, huge data. Telecom transactions. Or if I talk about e-commerce transactions, like Flipkart, Amazon transactions, huge data is getting generated everywhere. Huge data is getting generated everywhere, right? Yes. So everywhere, huge data is getting generated. And for storing this huge data means in petabytes, right? So if you talk currently we have got databases. Currently we have got databases like Oracle, MySQL, DB2, SQL Server, right? All this they are used for OLTP, online transactional processing. All this they are used for what? Online transactional processing for day-to-day operations. But we have got some specialized databases. We have got some specialized databases used for data warehouse purpose like Netija. We have got some specialized databases like Netija, Vertica, Teradata. These are used for data warehouse purpose, right? These are used for data warehouse. These databases are specialized databases. They can handle data up to some extent. They can handle data up to some extent, but beyond that. So for storing unlimited data storage, databases and specialized databases cannot handle unlimited storage, cannot store unlimited data. So as a solution to this storage level problems and processing level problems, we have got a framework called Hadoop. So before I go with the Hadoop, you need to know about the data, how the data is getting generated, how the data is getting generated, right? This is the data which has been generated from the last 50 years. Nineteen 74 to okay. Observe this. 2014 to 2024. See the last, observe this last 10 days, 10 years, sorry, with the previous 40 years. 20% of the data, what we are seeing in the current, see 80% of the data, what we are seeing currently has been generated from last 10 to 15 years. And previous 40 years, only 20% of the data is getting generated. reasons for the huge data generation, especially from the last 10 years, because of usage of technology, because of usage of smartphones, because of usage of internet, because of usage of technology, usage of smartphones, usage of internet, right? Huge data is getting generated, especially from the last 10 to 15 years. And the main sources from where this data is getting generated, mainly three sources of data. Mainly three sources of data. Social data, machine data, transactional data. Social data, social data, machine data, and transactional data. Data which has been generated from social websites, right? Like Facebook, Twitter, WhatsApp, all this we call such data as social data. Machine data, data which has been generated by reading or scanning the barcodes, RFID chips, such kind of data we call as machine data. And transactional data, data which has been generated from day-to-day transactions like bank transactions, telecom transactions. Yes. And this is going to occupy three formats, three types of data. You can see like three types of data. Three types of data, right? Structured data, yes, structured data, semi-structured and unstructured. Unstructured data. Structured data, data which is organized in the form of structured manner in the form of rows and columns, like database tables, DB tables, Excel sheets. Semi-structured data. Semi-structured data means data which is not fully structured, which is not fully unstructured, like JSON files. Unstructured data. Unstructured data like raw text, short messages. So this semi-structured means XML, JSON all comes as semi-structured. Short messages, raw text, images, videos, right? So the biggest challenge is today like handling this unstructured data. So databases can handle only structured data, but the biggest challenge to handle all varieties, structured, semi-structured, and structured. So Hadoop can handle all varieties of data, structured, semi-structured, and unstructured data. So day by day, as data is increasing enormously, as we need to have some proper storage systems, right, for storing and for processing it. So Hadoop, we have got a framework like Hadoop. So to handle as a solution to all the storage level problems and processing level problems, we have got a framework like Hadoop. Hadoop is mainly meant for two things, for storage and for processing. It is meant for storage and it is meant for processing. It is meant for storage, it's meant for processing. For storage, we are using HD. So, okay, it is performing storage and processing. Hadoop performs both storage and processing. If we talk, any technology performs either storage or processing. For example, C or C++ or Java or .NET. All this, they are meant for processing. They are meant for processing. And if we talk like Oracle, MySQL, SQL Server, all this, they are meant for storage. So any technology performs either storage or processing, but Hadoop performs both storage and processing. So for storage, does Hadoop use any databases internally for storing its data? No. It is going with Hadoop distributed file system, and for processing, it is going with an execution model called as MapReduce. It is going with an execution model called as MapReduce. For storage, HDFS, and for processing, MapReduce. Or currently we are going with Spark, MapReduce Spark. Okay. So you need to clearly understand. So when Hadoop is able to perform both storage and processing, what is the necessity of the current processing and storage technologies? When Hadoop is performing both storage and processing, what is the use of this means? You need to clearly understand Hadoop is for batch applications. Hadoop is for batch processing, for millions and trillions of records. For a single transaction, Hadoop is not required. If you are making a single transaction happen, go for databases only. Hadoop is good for huge data. Hadoop is good for huge data. Hadoop is bad for small data, right? And you may get a query, why databases like Oracle? So what is the drawback with the databases? Drawbacks with the current databases. Drawbacks with the current databases. Drawbacks with the current databases. First thing is, most of the databases limited storage. Most of the databases limited storage. And secondly, most of the databases with a limited storage. Yes. And no parallel processing in most of the databases, no parallel processing. Most of the databases, no parallel processing. And limited storage, no parallel processing. And next, see here, as volume increases, volume of the data increases, speed decreases. Volume increases, speed decreases here. For example, observe this query, select total amount, right? From sales one, total amount from sales one. It has got 10 records. Select the total amount. Select total amount from sales two. From sales two, which has got 1 lakh, which has got 10 lakh records. Select the total amount from sales 3. Total amount from sales 3. Observe. Here it has got a 10 crore. It has got 10 crore records. From query to query, as the volume increasing, right? Query to query, volume increasing. So which query is going to execute faster among these 3? Obviously, the first query with 10 records, right? Total amount of 10 records as compared with 10 lakh and 10 crore. So query to query, as the volume increasing, speed decreasing, right? Speed decreases, right? Next, if complexity increases, if complexity increases, right? Speed decreases, right? Yes, one second. If complexity increases, speed decreases. For example, observe this query. Same thing I'm taking, right? Total, let's select total amount from sales 1. Assume it has got 1 lakh records. The same way, select average amount. Sales 1 only. Select average amount from sales 1. Okay, same 1 lakh records only. Same table, right? Select the standard deviation, right? Standard deviation of amount. Standard deviation of amount from sales 1. Same thing. So which query is going to execute faster among these 3? Which query is going to execute faster among these 3 means obviously again the first query, because average amount is a 2-step process. First sum to be calculated, next average to be calculated, as compared to the first query. Second query is a time taking, right? And standard deviation of amount, a lot of internal processing is required. So query to query, even if the complexity increasing, speed decreasing, right? Yes. Databases can handle only structured data. Databases can handle only structured data. They cannot handle unstructured, semi-structured data. For example, just check with this. If I want to take reviews for a particular movie, reviews, a table. We have got a table. User and the review. User giving review. If the movie is good, for example, user 1, user 2, user 3, in this way 100 users are there. If the movie is good, saying 1. If the movie is bad, saying 0. If the movie is good, saying 1. Saying 0. Saying in the form of zeros and ones, right? So they are giving, okay, user 1, user 2, user 3. So 100 users, they are giving in the form of zeros and ones. Can you write an SQL query to count the number of ones and zeros? Can you write an SQL query to see the number of ones and zeros, right? How many ones and how many zeros means how many goods and not goods. Yes. Select review wise count. Review wise count I want. Review wise count from a reviews table. Group by review. Group by review. Select review wise count from reviews group by review. Observe this output. 1 and 0 review wise. The count 90 people saying the movie good, 10 people saying the movie bad. Okay, but generally reviews won't be given in the form of zeros and ones. They'll be given in their own text format. First person saying movie is good. Second person saying movie is not good. So in this way, in the own text format, they're given in the own text format. Movie is good, movie is not good, right? In this way, they have given. Can you write an SQL query now saying how many goods and how many not goods? We cannot write a query, right? Now we cannot, databases cannot handle this kind of data. Even by using keyword counter, it gives wrong computation because even not good has got good in it. So databases can handle only structured data. They cannot handle unstructured or semi-structured data. Hadoop advantages. First one, unlimited data storage. Unlimited data storage. Unlimited data storage is possible, right? Unlimited data storage. Unlimited data storage. Second thing is like very high speed processing. Very high speed processing. Unlimited data storage, very high speed processing. Can handle all varieties of data. Can handle all varieties of data. Fourth, it's an open source. It is an open source. No licensing is required. Unlimited data storage, very high speed processing, can handle all varieties of data. Open source. Commodity hardware. Commodity hardware. Unlimited data storage, very high speed processing, can handle all varieties of data. An open source. Commodity hardware, right? Okay. Commodity hardware means it can run on any hardware. Doesn't mean that you need to have the latest configuration. There's an open source. Most of these Hadoop products are from Apache. It can take from Apache Mirror site. No licensing required. Can handle all varieties of data, structured, unstructured, and semi-structured. Very high-speed processing because of parallel processing. Unlimited data storage. Huge data can be stored. Unlimited. Hadoop is proven in the market, storage point of view and processing point of view. Okay. There are many tests were conducted, right? For example, Yahoo has conducted a test. Yahoo has conducted a test. Yahoo has taken a table of 100 TB consisting of 1024 columns. 1024 columns. The task sorting based on 16 columns, sorting based on 16 columns. So time taken by different databases. Time taken by different databases. Oracle has taken nearly 3.5 days to process this. MySQL has taken nearly 6 days. Teradata, right? Specialized database used for data warehouse purpose. It has just taken 4.5 hours. One more specialized database used for data warehouse. Netija. It has just taken 3 hours. And finally, Hadoop has taken just 3.4 minutes. 3.4 minutes. The latest version of Hadoop just taken 1.2 minutes. So this is what the Hadoop speed has compared with the other databases. Whether these have taken days of time, have taken hours of time, these have taken minutes of time, right? 100 TBs of data, right? So Hadoop is proven in the market, processing point of view, and even storage point of view, right? Yes. And even Spark, even if we talk about Spark, very high speed processing, right? So just I'll give some overview about Spark, just 5-10 minutes I take. What is Apache Spark? Why PySpark? Why PySpark? Need for PySpark. Need for PySpark. Real life usage. Real life usage of PySpark. PySpark job market. What is Apache Spark? Why PySpark? Need for PySpark. Real life usage of PySpark. PySpark job market. Okay. So Apache Spark, it is an open source distributed cluster computing framework introduced by Apache Software Foundation. It is a general engine for big data analysis, processing, and computation, right? Why PySpark? It is a Python API to use Spark. Python API to use Spark. It's an open source cluster computing system used for big data solutions. PySpark is the lightning fast technology that is designed for fast computation. It is one of the demanding tool among the data engineers to work with bigger data sets. It is running distributed it's used for running distributed SQL, for creating a data pipelines, ingesting data into databases, for machine learning algorithms, working with the graphs and working with the data streams, right? Need for PySpark, if we talk huge amount of data, is getting generated both through offline and through online. This data contains hidden patterns, unknown corrections, market trend, user preferences, and other useful information. It is necessary that we need to extract valuable information from the raw data. So we require some efficient tools to perform different types of operations on this huge data. But there are various tools to perform multiple tasks on this huge data. But we doesn't have, okay, these tools are not so appealing. So we need to have some flexible and scalable, right, tools to crack a big data and gain benefits from it. So PySpark is such a kind. PySpark is such a kind, right? So the combination of Python and Spark. So combination of Python and Spark would be the very efficient way for the world of big data. So that's why Apache Spark community came up with a tool. It has come up with a tool called PySpark. It came up with a tool called PySpark, that is Python API for Apache Spark. Okay. And if we talk about the real life use cases, right, used in the commercial sector, like Apache Spark real-time processing systems, banks and other financial fields, they're using Spark to retrieve the customer's social media profile and analyze to gain useful insights, which can help to take the right decisions. The extracted information is used for credit risk assessment, targeted ads, and customer segmentation. Spark plays a significant role in fraud detection and in healthcare systems to analyze the patient's records and analyzing and identifying which patient is going to face the issue. And even in the entertainment industry, right? A popular OTT platform, Netflix using Apache Spark. It is using Apache Spark for real-time processing, personalized online movies and web series, right? So it processed nearly 450 billion events per day that are streamed over server-side applications. And even for trading and e-commerce, right? Websites like Flipkart, Amazon, all this they are using Apache Spark for advertising. And for tourism industry also, advising millions of travelers by comparing hundreds of tourism sites. Okay. PySpark job market. PySpark job market. So if you see the job market, right, PySpark job market, a lot of jobs for this PySpark. It has got a great demand, and you can see like huge salary packages for this PySpark especially. And the same way they'll be expecting the skills from you, right? Yes. Fine. You can just Google and check PySpark jobs and Hadoop jobs, right? A lot of jobs for that. You can see the course content, right? What I'm going to discuss as part of this. Big data Hadoop. What is big data? Why Hadoop? Drawbacks of these databases, sources and types of data, comparison with other technologies, RDBMS and Hadoop, advantages of Hadoop, Hadoop ecosystem components, HDFS, the first thing, right? Hadoop distributed file system, features of HDFS, name node, data node, blocks, configuring block size, HDFS architecture, name node, data node, secondary name node, job tracker, task tracker, yes, MapReduce architecture, processing domains, and the scoop for import and export operations, SQL and Hadoop. For importing data from databases to Hadoop and exporting data from Hadoop to databases for import export operations we use. Yarn. So during this import export operations, you can perform different operations, transformations, filterings, mergings, sortings. Yarn yet another resource negotiator. What is speculative execution, speculative job, speculative task? Comparison with the previous versions. Yarn components, different components, right? How the processing is going to happen within this yarn, and NoSQL database. What is NoSQL? NoSQL problems with RDBMS, types of NoSQL databases, different types of NoSQL in that one NoSQL database, that is HBase, Hadoop's database, right? And here we are going to discuss how to create CUDA operations, HBase use cases, their column families, HBase architecture, HBase data modeling, HBase CUDA operations, Hive and HBase integration, Hive introduction, Hive architecture, Hive metastore, Hive query language, differences between HQL and SQL, Hive built-in functions, loading data from local files to Hive tables, loading data from HDFS files to Hive tables, inner tables, external tables, Hive working with unstructured data, Hive working with unstructured data, Hive working with XML data, Hive working with JSON data. JSON data, Hive working with URLs and weblog data, Hive unions, Hive joins, inserting into local files, inserting into HDFS files, Hive UDF, Hive UDAF, Hive user-defined function, Hive user-defined aggregated functions, Hive UDF, user-defined functions, user-defined aggregated functions, user-defined tabular functions. UDF, UDAF, UDTF, user-defined functions, user-defined aggregated functions, user-defined tabular functions. Partition table, non-partition tables, multi-column partitioning, right? Partitioned tables, non-partitioned tables, multi-column partitioning, dynamic partitions, performance tuning mechanism, right? Yes. And bucketing in Hive, indexing in Hive, right? Performance tuning mechanisms in Hive. And so I'm going to discuss one storage component here, three processing components, MapReduce, Hive, and PySpark, and one NoSQL database, and also one streaming technology, right? Like Kafka will be discussed. PySpark introduction, why PySpark, need for PySpark, PySpark session, PySpark context, and PySpark RTD computations, operations on RTD, persistence options, PySpark core computations, groupings and aggregations, single grouping, multi-grouping, single aggregations, multiple aggregations, various actions and transformations, count by key, count by value, sort by key, union distincts, various count aggregations, PySpark SQL data frame, SQL AP, data frame API, how to create a data frame API, and PySpark creating a data frame, creating an empty data frame, convert RTD to data frame, convert data frame to pandas, PySpark show, struct type and struct field, row class, column class, select, collect, with column renamed, where and filter, drop and drop duplicates, order by and sort, group by, John, union by name, UDF, map, flat map for each sample, pivot, partition by array type, map type, PySpark SQL functions, PySpark aggregate functions, window functions, data and timestamp functions, JSON functions, reading and writing JSON file, PySpark built-in functions, when expr lit split, substring, translate, overlay, to timestamp, to date, months between, explode, array, collect, set, map keys, map values, struct. So many built-in functions with many working examples. PySpark external sources working with SQL statements. Spark and Hive integration, Spark and MySQL working with CSV, working with JSON transformations actions, narrow and wide transformations, adding of new rows, dropping rows, handling nulls, deployment modes, local mode, cluster mode, PySpark applications, stages and tasks, drivers and executors, and building applications, pipelines, deploying Spark apps, performance tuning, PySpark streaming concepts, PySpark streaming, right? And the integration with Kafka and PySpark ML. And also for this PySpark, you require Python, right? Total coding goes in Python, total implementation in Python. Even Python, both core and advanced, both are discussed. What is Python? Why Python? Applications, features, versions, Python operations, modes, interactive mode, batch mode, various editors and IDEs, integrated development environments, constants, data types, variables, comments, escape sequences, strings in Python, right? And operators in Python, Python IDEs, Anaconda, Prompt Anaconda Navigator, Jupyter Notebook, Spider, Eclipse, VS Code, flow control statements, looping statements, strings in Python, string indexing, string slicing, string functions, string methods, string special characters, collections, list tuple sets, dictionaries, Python lists, list operations, list indexing, list slicing, list functions, list methods, list addresses, tuples, sets, dictionaries, functions in Python, modules, modular programming, renaming a model, reloading a model, normal import from import, package in Python, errors and exceptions, file handling in Python, object-oriented programming concepts, regular expression module, extracting data from the given data, database connectivity, installation of database, Python data and time, operating system module, and advanced concepts like iterators, generators, closers, decorators, working with CSV, XML, JSON, graphic programming, and Excel workbook, data analytics, introduction to this data science, Pandas model in brief, NumPy model in brief, and Matplotlib model in brief. So this is what I'll be discussing, right? Yes. So here mainly four things: Hadoop, PySpark, Linux, and Python total core and advanced, right? This Python nearly like 50 sessions will be there on this. You can attend for this. You will be attending regular sessions, right? From Monday to Friday. So here Monday at 8 a.m. there is one session, one Python batch. You can attend this. Means Python you need to attend separately because it is time taking. Or Thursday there is a batch at 8 p.m. This the coming Thursday. IST timings, right? 8 a.m. if you want morning or evening, right? And this Hadoop, PySpark, and Linux, it goes for nearly 12 weekends. 12 weekends, right? Saturday 2 hours, Sunday 2 hours. All right. 5 to 7. 5 to 7 will be right. And the fee structure is 15,000 for this. In brief, in depth, we will be discussing all this. 15,000 for this, right? Any queries from your side? Tomorrow also you can attend the session at 5 o'clock. Same time, using the same link to see more discussion on this, right? Yes. Any queries from your side?
Sir, will you continue this batch because we have very less strength, right?
Hello? Yeah, no, it will be continued.
Because only 2 members joined, right? That's why I have that doubt.
No. Some other students also are available who are attending Python. They are looking for big data to start. They are attending
Okay.
already Python sessions who have got enrolled for these packages.
Okay.
They already attended this demo, Hadoop demo, but they are attending for the regular sessions to start.
Okay, sir. Thank you.
Fine. So tomorrow also you can attend to see more discussion on this same time at 5 p.m. using the same link, right? Yes. Fine.
Okay, sir. Thank you.
Yeah. So in the last class, just we had an introductory session, right? What is big data and why Hadoop drawbacks with the current databases? Yes, big data like huge volumes of data. So currently we have got databases for storing the data like Oracle, MySQL, DB2, SQL Server, and we have got some specialized, just I'll take 2 minutes what we have discussed in the last session. Specialized databases like Netezza, Vertica, and Teradata used for data warehouse purpose. But these databases and specialized databases, they can handle data up to some certain extent, right? Beyond that, they cannot support, right? So we have got, so as a solution to all the storage level problems and processing level problems, we have got a framework like Hadoop. Hadoop is mainly meant for two things. Generally, any technology used either for storage or for processing. They're used either for storage or processing, but Hadoop is used for both storage and processing. Yes. Meant for storage and second meant for processing. It is meant for both storage and processing. Hadoop is meant for both storing data and processing data. We talk about like C, C++, Java, .NET, all meant for processing. Oracle, MySQL, DB2, SQL Server, all meant for storage. But Hadoop performs both storage and processing. For storage, it doesn't use any databases because databases has got a lot of drawbacks as compared with this, right? So Hadoop is going with a special kind of file system. It's going with a special kind of file system called as Hadoop distributed file system. And for processing, it is not going with any, for processing, it is not going with any current technology, right? Yes. It is going with an execution model called as MapReduce, and currently we are using Spark. Spark, very high speed processing technology, processing huge data in quick time. All right, yes. So for storage HDFS and for processing MapReduce on Spark. Yes, drawbacks with the current databases, drawbacks with the current databases, but limit. Okay. So if it, before I go with the drawbacks with the databases, you may ask why if Hadoop is there for storing and processing, what is the use of the current processing technologies and storage technologies? Already Hadoop can perform both storage and processing. Why again this storage and processing technologies? You need to clearly understand, right? Hadoop is for batch applications. Hadoop is for batch applications. Sorry. Hadoop is meant for batch application. Hadoop is meant for batch applications. Hadoop is meant for batch applications. So there are two types of application. What do you mean by batch application? There are two types of applications. There are two types of applications. The first one,
online applications. Second is like batch applications. So what is the difference between these two? Online applications and batch applications. Hadoop is not for online applications. Hadoop is meant for batch applications. Online applications, user interactive applications, user interactive applications. User interactive applications. Here user gives the input. User interactive applications, here user gives the input. User gives the input. Example, booking a movie ticket. Booking a movie ticket. Making an online transaction. Making an online transaction. Booking a movie ticket, making an online transaction, right? So here compulsory, yeah, the user need to use the input, like source account and destination account. User has to provide that how much amount to be forwarded and what is the source account, what is the destination account. User interacts. But batch application, user non-interactive applications. User non-interactive applications. User non-interactive applications, right? So Hadoop is meant for this user non-interactive applications. Here user is nowhere required. User is nowhere required. User is nowhere required. Here example, railway ticketing PNR status. Railway ticketing PNR status, currently our status is 2